Here's 2.24. We're given a few conditions. A union B is a subset of C union D, A intersecting B is the empty set, and C is a subset of A, and we're asked to prove that B is a subset of D. I'm going to start by using the condition that C is a subset of A. Then we know for sure C union D will be a subset of A union D. Which means A union B is also a subset of A union D, because we know that A union B is a subset of C union D. Now, we're asked to prove that B is a subset of D. What if we assume that B is not a subset of D? So if we start from here, we're actually trying to prove by contradiction. If we assume that B is not a subset of D, that means there will be some element, let me call it X here, which belongs to B and which won't belong to D. Now, since X belongs to B, that means naturally X will belong to A union B. And we know that A intersecting B is an empty set. That means X cannot be from A, because X belongs to B and A intersecting B is phi. So X cannot belong to A. Meanwhile, we also know that X doesn't belong to D from here. That tells us X doesn't belong to A union D. But that's a contradiction, because we have that X belongs to A union B and A union B is a subset of A union D, so this shouldn't happen. Now, what does this mean? That means our initial assumption, which happens here, is a wrong statement, which means B should be a subset of D. And that's the end of the proof.